Hi, my name's Debbie Scott. I am a student in the COM 212 Public Speaking course, and as part of my presentation, I'll be talking to you tonight about nuclear energy, some of the pros and cons. I chose this subject because it was a focus of the focus group that we did early on in our course. It's important, I think, to a majority of people, certainly myself, and it affects myself and my children and their future generations. We need to think about viable and alternative energy sources. In this day and age for our future, major concerns facing us today are the release of carbon dioxide into the atmosphere that contributes to the greenhouse effect. Our habitat is currently threatened by changing weather patterns, disappearing animal species, and poor air quality. As well, a huge concern is that fossil fuel reserves are very limited, and scientists are looking to the end of these reserves by approximately the year 2052. So I'd like to take a minute to just describe what nuclear power actually is. Nuclear power is the use of nuclear reactions that release nuclear energy to generate heat. And that's most frequently then used in steam turbines to produce electricity in a nuclear power plant. So how does nuclear power work? Just as sort of a simplistic explanation, if you think about all things around us are made up of atoms. So the mass of each atom is primarily concentrated in the center, called the nucleus. A cloud of electrons forms the rest of this mass and surrounds the nucleus. The nucleus is also made up of subatomic particles called protons and neutrons. So the nucleus of a very large atom can split into two. This is called nuclear fission. The large atom's mass is converted to pure energy by this process, and it produces a tremendous amount of energy. So you remember Einstein's formula, E equals mc squared. So m is the small amount of mass, and c is the speed of light. I'd like to provide a brief history of nuclear power and how it's developed in our country. This energy was discovered in the 1930s and 40s, and its potential as a weapon was quickly realized. The Manhattan Project, which Albert Einstein was instrumental in, was created in 1939, and this is at the beginning of World War II. Albert Einstein urged Franklin Delano Roosevelt to consider working on developing an atom bomb. Albert Einstein realized that scientists in the U.S. and France had been conducting research, and that made that possible to trigger a nuclear reaction. This would unleash an enormous amount of energy, and Einstein proposed a collaboration of other scientists to establish the atom bomb. He was very worried about this technology going into the hands of the Germans and affecting the outcome of the war. This technology then, after the war, after World War II, was used and developed for the nuclear navy and then in the public sector. And that's where commercial power plants were developed for the provision of electricity. The first commercial power plants, nuclear power plants, were created on May 26, 1958 in the United States. As the nuclear power industry grew, there were two governing bodies, which grew into two distinct groups in 1974. The Department of Energy, which was Research and Development, and the Nuclear Regulatory Commission, the NRC, was developed. There are now 61 commercially operating nuclear power plants in 30 states in the United States. However, the Entergy Corporation plans to shut down nuclear power plants near Syracuse, New York, and Boston, Massachusetts before the end of this decade. So, when talking about nuclear power, one of the biggest concerns is environmental. Society is very polarized on the use of nuclear energy, particularly on the risks of exposure to low levels of ionizing radiation. Nuclear energy really fell out of support a few years ago. There have been no new plants created in decades. Um, the Fukushima, Japan nuclear disaster in 2011 really fed into this public dislike both in the U.S. and the rest of the world. There's a great deal of pressure on the U.S. to reduce greenhouse gas emissions, and nuclear energy is being increasingly seen as part of the solution. As part of the Paris Climate Agreement, which was held in December 2015, there was a collaboration and commitment on behalf of 165 countries to take concrete measures to reel in planet-warming carbon emissions. What are our current options when we think about alternative sources of energy? Solar and wind renewable sources have grown recently, but nuclear plants still provide almost 60% of carbon-free power. Advantages for nuclear plants are that they produce steady power and can run at more than 90% of their capacity. This is higher currently than gas and coal facilities. So when you talk about the argument for use of nuclear power, there's cons and pros. Starting with the cons of this, some long-standing concerns are that the waste disposal as a result of the radioactive materials is a huge concern, where to store it, but also that it needs to be carefully monitored for potentially thousands of years. The safety record. So the magnitude of a failure, when something does go wrong, such as Fukushima and the Chernobyl disasters, the magnitude of this is enormous. This could have potential global ramifications. There's potential for a nuclear power plant to become a weapon-making factory. A growing concern recently is that these could be targets of potential terrorist activities, as global safety is becoming increasingly hard to monitor. Uranium is quite scarce, which is needed as a part of this energy source. The estimates by scientists are that we only have enough for the next 30 to 60 years. There is a high cost and time investment to construct new nuclear power plants, between 5 to 10 years. The majority of the existing plants now are over 30 years old, so it's becoming an aging problem with the existing plants. On the other side of the coin, those who advocate for nuclear energy feel that in spite of these very real issues, nuclear energy could be the country's largest source of clean energy. There's very little in the way of carbon dioxide produced, therefore little greenhouse gas emissions. There's already well-developed engineering knowledge in place, so this isn't something that would need to have further research and development. One plant can generate an enormous amount of power. As I mentioned earlier, quite a number of the existing nuclear reactors are more than 30 years old. Many of these reactors opened before deregulation. And this is not an immediate solution. So if we were to construct a new nuclear power plant, it can't be an immediate fix. There's a range of 20 to 30 years which would be needed for formalities, planning, and building activities. What is the future of this power source? Is it a supportive? Is it a major role? Is it not a role at all? Many people argue that nuclear energy is not sustainable and creates new woes. The waste can cause serious concern in the immediate future, but for future generations, as I mentioned, the monitoring of the waste has to go on for thousands of years. Uranium, like natural gas, is only available in limited quantities, and it won't be available for future generations. Others feel, though, that since even though uranium is scarce, there's only a very little needed to produce this energy. So a nuclear reaction releases 1 million times more energy than traditional energy sources. Nuclear energy also provides a continuous supply. The existing plants are widely available and may last another 100 years, while natural gas, coal, and oil are not. In conclusion, I'm hoping to provide you with some food for thought, for a balanced viewpoint, because I think we'll see much more talk and much more activity and interest in the use of nuclear power. I would say this is a very cautious endeavor. The stakes are high, and what can happen when things go wrong can affect the world at large. Our current energy needs dictate that we develop energy sources that are sustainable and take the environment into consideration. Thank you very much.